Alrighty. Alrighty. 3 seconds.
Alright. Holy shit. My finger was stuttering. My finger was doing this. My hand was doing this. I don't know what the hell's happening.
Alright, let's see.
Can I teach now? Can I get back to teaching?
Nice.
Sure.
Alright, guys.
I was gonna be a little late, but
The oppositions were hating.
see.
So
We got, I think these are them right here.
we're gonna get the button back. Right. We're gonna get a text.
I'm just gonna grab this here.
We're gonna make it say that if they are the authority. So if I click the button, it won't do that.
Yeah.
But if you it will.
Authority in the room. Authority is Winter.
Considering that,
Authority.
use it,
Authority. No. See who it is. You can see who it is. Just hover over it. There you go. There's well.
I see voice lines, so that's good.
You gotta set up like gotcha. Hey, well.
For some reason.
Hey guys, yeah, my VR is like dying or something, so I'm just gonna do this on screen.
All right. He's teaching. Let him cook. All right. Bill, I think you're the best person to kind of describe them.
Have we taken the photo yet?
Yeah, we just did.
Oh,
But we
sure.
can.
Snug says he's coming. He's just running late.
Yeah.
Okay, everybody, so we can get started. Today we're going to be going over networking, and networking is one of the most powerful features in circuits. It's one of the main differentiators between CV1 and CV2, and it opens up a lot of flexibility, and it's a really powerful feature in the language. So basically what networking is every time you run circuits, you're running them locally on one person's device. So if I'm running circuits, the actual execution could be entirely different from what somebody else is running. Obviously, the chips are going to be the same. So if I'm seeing a circuit here, like a chip and a wire, everyone's going to be seeing the same thing. So that's all completely synced, just automatically. You don't have to worry about that. But what actually can be networked is what's running, the values that's in a variable, or whether or not something is currently running or not running, certain values that will diverge in an if chip. So there's a handful of chips that you can use to work with networking. There's actually not too many. I think this is pretty much all of them, but it opens up a lot of flexibility in the system, and you kind of have to familiarize yourself with the nuances and learn how to work with the system. And once you do that, you kind of get an intuitive understanding of how networking works. You can make a lot of things. Snug, are you on your phone?
I think he crashed. He just crashed.
He probably was on his phone. I think it's coming back for real in a second. So going through some of these chips, a lot of these involve player authority. So I'll explain what authority is first. So anytime you're in a rec room, just any instance where you can see players and you're a player, there is a concept of authority. There's two types of authority. There's room authority, and there's object authority. So if you load into a room and you create the instance, there's nobody there, you will be the room authority. Room authority means that every object that's in the room, you're just authority of the object by default. Also, kind of in circuits, sometimes if you're running logic, you just want one player to run it, you usually just do it off of player authority, so you have one person doing it. It's just a good, convenient way to pick the main person. You can kind of think of it as the server. So if you play a traditional game, Rec Room doesn't actually work like this. We all just run off authority. But if you're playing a traditional game like Minecraft or whatever, there's a bunch of code that's only running on the server. That's kind of what authority is. And then there's also object authority. So as I said, the room authority will by default be authority over all objects when you like freshly load into an instance. But object authority can change. So for instance, if I have like if I spawn in a basketball and it's like sitting on the floor, and then you load into the room, the person who loads in authority, there'll be authority over that ball. And if somebody else joins the room and they touch the ball, literally touching it will convert the authority over to them. You can kind of tell who's authority, like based on whether or not, like if it's lagging. So like sometimes like if somebody spawns in something and they throw it, it might look kind of laggy for you, but it looks kind of like a lot more smooth to the person throwing it. That's because they're authority over it, and they're the one who is sending out like the network information to other people on where the actual position of the basketball is, since they're running the physics simulation. So with that said, let's look at some of these chips. First, we have the get authority chip. Authority is always a player, by the way. So these chips that output authority will always give you a player output. And if I hover over that chip, it'll tell you who the authority is in the context. You'll notice there's no inputs to it, which isn't like you might be wondering, like, what are the authority? What is it getting the player who's authority of? So if it's just like here, just like sitting out at the room scope as it is now, that will give you room authority. So whoever the room authority is will be output in that chip. However, if I were to take that chip and I were to put it into an object board, it would now give me the player that's authority of that object. So if it's like a button, if I put it inside of a button object board, and then another player selects that button, it'll transfer authority over to them, and they're the player that will be output by that chip. Below that, we have if local player is authority. This one pretty much does what it says. You run it, and if you yourself, the person running the chip, is the authority in the local context, following the same rules as this upper get authority chip, it will run this first, I'm authority output, and if not, it'll run the lower, I'm not authority. It's basically just like an if chip, as if you were to wire up this get authority like equals local player into it. Below that, we have player get is authority of. This takes an object and then a player, and it tells you whether or not the player that you gave it is authority over the object that you give it. Just true or false. Sorry, figuring out screen controls. Rec room object get authority. This just tells you if the player you give it, or object get, yeah, this just gives you the authority player over the object that you give it. It's kind of like get authority. It's very similar, except that instead of having to be in that object board to get the authority over that object, you can just give it a reference to that object, so it can just be anywhere, and it'll tell you who the authority is. Rec room object get is local player authority. You'll notice a lot of these chips do similar things. Like you could recreate a lot of these chips with the other chips. They're kind of just there as a convenience. So with this one, you just give it an object, and it returns true or false whether or not you yourself, the local player, is the authority over that object. And then lastly, in this section, we have rec room object set authority. This one's actually in beta, so if you're not in the beta room, you won't be able to see it. What this does is you can actually like manually change the authority of an object in circuitry. So this can be useful if, for example, you have like a piston and you want it to move smoothly for one player. You could set them to be the authority over that piston, so it would look a lot smoother. Whereas for everyone else, it will look a little jittery because it's like coming over the network from whoever the actual authority is. And the way it works is you just give it a player in the authority port, and then an object in target. And when you run it, it'll switch over authority to be that player you give it. Over here, we have get local player. This, as you would imagine, just gives you a reference to the local player. So if I were to hover over the output to this chip, it would say Wilchill. If Dootman were to hover over this, it would say Dootman. So you'll notice, even though it's the same chip, because like I said, like circuits have like their own different like state for everybody. It will return differently depending on like which client you're on. Below that, we have player get is local, and that has a target input port, which is a player. And as you can see, I should explain this real quick. That's a player input, and if you hover over it, it says local player. We covered this briefly when we went over like port types in the beginning. But if you have a player port and it can only be a player port, it has a little convenience where it will default to the local player. So like there's a get local player chip up here, which can be useful if the port accepts, like, for example, either an object or a player, and you need to tell it to give it a player specifically. But if it only takes a player, it'll just default to local player, which will just be you. I can actually click on it, and if I click on it, it'll toggle into invalid player. And that can be useful if you're just like instantiating like a player variable to some like null state, for instance. But anyway, this player get is local chip just tells you if the local player is local. So if I put literally local player into it, that will always return true, no matter who you are, because the local player is always local, and that would always be true for you. If I were to get like a hard-coded player, like if I were to take it, like put a button down, and somebody were to press it, and it has like a little port saying who pressed the button, that would be the same for everybody because everybody saw the player press the button. So if I wire that into here, this chip would only return true for the player that actually like pressed the button. If player is local, this is an execution. This is kind of like an if chip, like combined with the chip above it. It's just like a little convenience. You give it a player, and then you run it, and the top port runs if they're local, the bottom one runs if they're not. We have a few more chips. These are kind of just also conveniences. Nothing you can't do. Like if we didn't have the chips, you'd be able to recreate their functionality otherwise, but they make things a little simpler. So this one is if player is valid and local. So you run it, you give it a player, and it's very similar to the one above it if player is local, except that it will also check if the player is valid. So if you, for instance, saved a player into a player variable, like a synced player variable, and then they left the room, they would suddenly become invalid because like you can't operate on a player that's not in the room anymore, which is why they're invalid. And if you try to check if an invalid player is local, you will actually get an error. So normally to get around this, you would use the isValid chip. Like the chip is literally called isValid. Let me pull that out. This chip takes pretty much anything in. Let me verify the port type. Yeah, it takes any input. Usually you'll use it either with a player or an object, and it will tell you true if the player or object is valid and false if not. And you like normally you would use this to check like if they're not valid, you wouldn't do whatever logic is going to give you an error, checking if they're local. But this chip here, if player is valid and local, kind of lets you just skip over that, saves a step. So there's 3 outputs. The first one will run if they are both valid and local. The second one will run if the player is not valid. And the third one will run if the player is valid and they're not local. And then this bottom one, if local player should run, you'll see this a lot in like default component object boards. So like if I were to spawn in a button right now and open up the board, the player pressed and like player released events, those don't just go directly into the output of the object board. They go through these things first, which is why if I were to put down a button and press it, the output will only run out of the board for the player who pressed it. So like things are kind of set up like that by default to make it so networking isn't usually something you have to think about unless you're doing something more advanced. So the only difference between if local player should run and if player is local is that if the player you're putting into it is not valid, it will just run it on authority instead, like the I think object authority. I actually don't use this chip much. I usually just use if player is local. And then we have some things related to room authority, which I was talking about earlier. Let's talk about this one first, get room authority. Room authority is actually a wonder. I guess we're probably the first one here. That's usually how it picks room authority. Generally, it will try to assign room authority. So first of all, when somebody joins a room, they're room authority until they leave. So like as soon as somebody starts up the instance, they're always going to be room authority until they've left the room. And then at that point, it will try to reassign room authority to somebody else. And the logic it uses to assign the new room authority is it generally tries to pick the player that has the most capable hardware to like run the room in, because the authority player is going to be like running a lot of logic, both in circuits and just like internally in Rec Room code. So we try to find like the player with the strongest hardware. It usually prioritizes like PC on top, and then like console, and then like mobile, like VR, like standalone VR, and then like mobile players. It also factors like ping into that calculation. So if you have a really bad ping, you'd be deranked. There's no way to manually pick room authority. It will just kind of pick it for you after like it does a reassignment when somebody leaves. But there is one thing you can do. This bottom chip, recalculate room authority. This will trigger the calculation to happen automatically, like in circuits. So Wonder is currently room authority. If I were to run this, it would look at every player in the room and see if there's like somebody else on like more capable hardware. And if it does find somebody, it would transfer room authority to them. So this get room authority chip would start returning them instead. The CV1 game chip actually does this when you start the game. So we added this chip for parity with CV1. This second to bottom one, if local player is room authority, this is very similar to if player is authority, except that instead of being like scope dependent, getting the authority of the object board you're in or just the room scope, it will only look at room scope. It's actually identical to running this if you like. It's the same as if you ran if local player is authority, just like where it is now, just at room scope, since the room scope authority is room authority. And then lastly, we have an event receiver here. Event receiver room authority changed. This, as you can imagine, will run when room authority changes, either when the room authority leaves or you manually change it with recalculate room authority. There's also a similar event. Oh, also this one has an output new authority. It's just the player tells you who the new authority player is. Like you could just get it from get room authority chip, but the port's kind of just there as a convenience. I think that's pretty much. Oh, we do have one more event receiver. Similar to room authority changed, there is just a regular authority changed, which is available inside object boards. So for instance, if I had like a button or whatever, and I could put down an event receiver, configure it to room, configure it to authority changed, and it would fire with the new authority. It looks just like this one, except it doesn't say room authority; it just says authority changed, and that would run whenever the authority of the object was changed, such as if somebody like touched the button, or if no one had touched it yet, and it was still being determined by room authority, and then room authority changed. Cool. I think that's it for the chips. Any questions?
Any questions?
Cool. Snug, did we have anything up next for this?
Now we would probably go to the example. I want to add one more thing to if local players should run. Like Will said, if the player is invalid, it runs off of just authority. But think of it more as like it runs off of room authority if the local player is authority, because it's not gonna like send out a network tick to authority for them to run it. It's just not. No one's gonna be true on that if the local player itself isn't authority. Yeah, that's it. So now should we go on to a example? Do we? Oh,
Yeah,
did
yeah,
you already
yeah,
do
yeah,
events?
Oh, events. Yeah, you can do that.
So let's move these out of the way. Never mind. Someone else got it. So close.
No, that one I couldn't select that one when I was selecting them.
All right. So we went over events in the last class, especially custom events. So if you make a custom event, let me just make one real quick. I'll do it. Call it. I'll just call it test again. And then I assign test to both of these. Now these are linked, and when you send a signal through the first event, it'll just get received over here by the same person who sent it. But notably, you can actually configure the event, and I'll let Doomman do it so you guys can see it. if you look up here, right under where you assign the event, we have the target. And if you click on target, this is high quality. I'm gonna steal this share screen and share my own because it's gonna be easier to see on mine. I can't select it.
I think,
Dude,
all right, I think you're
Got-
good now.
drop your pen.
I think you're good now.
Oh, okay. So if we look in here, we have the target, and then in here we have a ton of targets. Starting off with the default, which is local player, and remember, local player is just yourself. So whoever sends this event is going to be the exact same person to receive it. You can send it to all players. So when you send the event, the receiving end of that event will go off for everybody in the room. Then we have authority. Will already went over what authority is, object authority and room authority. If it's outside of just an object scope, it's in world scope, then it's going to go to room authority. Otherwise, it'll be just authority of the object. Then we have others. Others is everyone except the local player. So whoever sent that event, they're not going to receive it, but everyone else in the room will. That can be useful sometimes. Player is super neat. It lets you put a specific player that you want to receive the event into this port. It adds an additional port to the sender. And then on the receiving end of this event, only that player will get it. Not the person who sent it, not everyone in the room, just whoever this player is. Right now it's local player, so whoever sends it's gonna get it. But if I set that to like me, no matter who sends that event, I'm gonna receive it. And then the last one is room authority. Whoever sends it, the receiving end of that event is gonna be room authority. All right, does that make sense to everyone? How that works? That checks out. All right. Now, let's go on to the example.
Okay, so for the example today, I'm going to show you a couple ways that you can use networking to change the state of a set of lights in the room. You want them to be the same for everybody. And there's two ways you can do it. One way is very hard on networking, and one way is less hard. One way is a little more optimized. I'm going to show you the less optimized way first. So let me turn off push to talk so I can actually build and talk at the same time. Okay, cool. So what we want to do is you want to have a button. So let me take out a button. And when we press this button, we want it to toggle a bunch of lights. Light toggle. Cool. And as I said earlier, when you press this button, there is a button pressed event inside of it, and that event will run for everybody in the room. But normally, when you have a button like this and you press it, only runs for the player who presses it, right? That's because we have that if local player should run chip inside of it that's filtering out everybody other than the player who hit it. So that's fine. We only want it to run for the person pressing it anyway. So let's take out a bunch of lights now. And we're going to use events, as we talked about yesterday, to actually like convert the signal from. Oh, on the upper one? Yeah, sure. Okay, I'm sharing my screen up above on top as well, if anyone would like to look at that. And we want to use events to go from the button to all of the lights. So let's take out an event definition, and we'll call it something like light toggle. Cool, so I've renamed it. Now I'm going to add a property. We'll set it, well, it'll just be a bool. Let's say if it's on or not. Cool. So when we hit this button, on second thought, let's make this a toggle button because that'll more closely represent the toggle state of whether the lights are on or not. Cool. And the events work exactly the same as the regular buttons. Okay, so on button pressed, we want to send out an event, light toggle on, right? So let's take out an event receiver. And we're going to hook it up into the pressed event. Oh, sorry, that's the receiver. I meant sender. We are going to need this receiver later for the light. So we have the event sender. Let's configure it and set the event to light toggle. And let's leave it as local. And when we hit this button and when we press it, we want to turn the lights on for everybody. So let's hook that up to pressed. And we have this port here. Right now it's just defaulting to false. Let's hit that and turn it to on. So when we hit the button, it's going to send out the light toggle event locally. So only for me. This output on the button is only running for me since I'm the one who pressed it. And then this event is also set to only local. So the event sender, the event receiver is over here. Let's configure this one to the same event. That's a ton of events. Here we're actually trying to update that UI, by the way. So hopefully that will be a little easier to find in the future. So here we have the event. You'll see that like the light doesn't accept a bool, has turn on and turn off. That's pretty simple to work around. We can just take out an if chip. Cool, and now I can just wire this up directly into the if chip, the ports too, the on port. So when on is true, we want to run turn on, and when on is false, we want to run turn off. So let's try that out. By the way, I haven't touched this light at all, so it will default to synced. So whatever I see on this light, regardless of what else I'm doing in circuitry, will automatically be the same as what you're seeing. So it's currently already on, so when I hit it the first time, nothing will happen. But when I press it again, oh, I haven't hooked it up to the off yet. So let's put down, we can just clone this event sender. And we want this one to turn it off. So let's hook it up to the released. So that's hooked up to there. Let's hit this on port. So we want it to set to false. We want to turn the on state off. We want to set it to false in the enabled state. So let's hit it again. Cool, and that has turned off. So now when I hit it, it's going on and off. Cool, so that's one light. Let's say, for example, you want to have a ton of lights. So let's take this one light, and we're going to clone it a bunch. And because they're events, it's not physically wired up to any of like this on-off apparatus over here. So I can just clone it as an independent like set of circuits. So let's do that. I'm not sure what just happened there. Okay. And let's clone it again. Is there a weirdly large stretch here for anybody else? Okay, that's weird. Anyway, it doesn't impact the way it runs, so we can just run it as usual. So we have, let's get one more. We have 5 lights here. So now when we run this, they'll all turn on and off. So that's good. Let me take out my tool tab, however, so you can see this as I'm pressing it. So I don't think we've discussed the concept of network heat before, but in addition to CPU heat, so you can see on my menu here. Let me redock this real quick. So up here, of course we have ink. Everybody knows what ink is. That's just like how much stuff you have in a room. It's worth mentioning that it's not in rooms too, since we don't like strictly enforce the amount of things in your room. But on the circuit side, we have, first of all, chip count. It looks like there's 1,157 chips in this room out of 5K. That's just how many chips you can have. That one's pretty straightforward. Typically, we have CPU heat. This is like the most typical straightforward constraint that you might be running into in like normal circuitry. It looks like it's at about 2% right now. That's probably because there's some 30 hertz event receiver somewhere to like some background system to keep you in the room, for example. That's just like that value goes up as you run chips. Like every chip has a different amount of heat associated with it. So a typical chip, like an IF chip, for example, you can run about 4,000 of those at once before you run out of CPU heat. Something like a little bit heavier, like a delay chip, which actually has to like allocate memory on your computer, that takes up. You could run about 400. It's like 10 times more expensive. But there's also network heat. So this is a measure of how much data you're sending out over the network on your local client. So there's actually two parts of it. There's this percent part here. I don't know how visible this is on the share screen, but you can look at it on your own tools menu. On the left of this little bar, it says 0%. And then on the right, it says 0 out of 5. So of course, those are both at 0 right now, at least for me, because I'm not sending anything out. The percentage on the left, that's how much data you're sending out, like actual, like it counts like the actual like bytes, like the ones and zeros that you're sending out to other people. So if I send out, if I get a networked event with a bool, for example, like just like this one I have here, this light toggle event, it has a bool parameter that's on. This is kind of getting a little technical. Normally, like you don't have to know this, but a bool is 1 byte, which is 8 bits. A byte is usually like the lowest like unit of data that you deal with on computers. So it's just sending out 1 byte. That percentage is an actual count of how many bytes you're sending out. If I were to send out a string, each character in a string is 2 bytes. So it'll multiply the length of your string by however many, multiply 2 bytes by however many characters are in that string. So longer strings, if you're sending out, like if I were to add a string to this event, and right now the event, by the way, in my current setup is set to local only. So it actually won't take anything. But if I were to configure these event senders and make them go out to everybody else, as Snug was showing earlier, then it will start taking network heat. The other side of that, let me get this guy to stop sending me requests. The other half is RPCs, 0 to 5. That's how many RPCs you have. An RPC stands for remote procedure call, which sounds kind of technical, but basically all it is anytime you're sending out, anytime you do something that sends out data to other people, like regardless of how much data is in it, like if I were to send out one event that had a ton of like properties on it, like if I added like 10 strings on here and I send that out, that would take up 1 RPC. If I were to make 10 different events that each had 1 string in it, that would take 10 RPCs. So even though like it could be the same amount of data, you generally want to like group your things together as much as you can into like a lower number of RPCs. And it's also worth mentioning that the specific numbers you're seeing here, right now they're 0, but you can see the 5. That's like the maximum RPCs. There's also like a number of bytes you can send out until that hits 100%. Those will actually change depending on how many like people you've set the maximum capacity of your room to. So this room is probably set as something like 40 people is the max. That will, like, the more people you allow in your room, the lower, like the more restrictive your network heat becomes, because you're having to send that data to like more people. So if you, I think the lowest is like 8 or 12 or something. If you set your room count lower, you'll actually be able to send out more RPCs. And just like CPU heat, if you exceed it, you'll get like a circuit error and your circuit will just shut down for like a second. But anyway, back to the example, now that that has been explained. So we have this button, which is turning the lights on and off. So if I take out my tools, and if I hit the button, you can see my network heat is going up. These are all synced, right? Cool. Right now, there's only a few lights, so it's not really too much of a problem. But if we were to add a ton more, like that's spiking at like 8% or so. So if you had a room like full of lights, or we're just using lights here, but this would apply for any component that's synced. So if, for instance, you had, I don't know, like an invisible collision that you wanted to turn on and off in various regions of the map. After, like, for example, if you had like some game start event and you want to turn off a bunch of invisible collisions so people can actually like freely walk about, the same thing would apply here. So this is taking some amount of network heat. It's not terrible, but it's not that great either. So there is a better way that we can do this. If we slightly change up our networking, we don't actually have to make too many changes to what we have here. So if you think about it, when I press this button, it's sending out this event locally, just for me. Like, you don't know that this event is being run at all. And then I run these event receivers here, the light toggle, and then it hits the light, and the light is either turning on or off. Like, I'm running that action. And then because it's synced, I'm sending out that information to you for every single light, telling you that the light is being turned on or off. But like in reality, they should all be the same. So we probably shouldn't be networking the lights themselves. We should be networking the actual event that turns them on or off. So I'm going to configure all of these lights and just turn synced off on all of them real quick. Cool. And now when I run this, you actually won't see any changes. It'll only change for me. Like, you can probably see it on my screen that they're actually turning on or off, but that shouldn't be happening for you. But what we can do is we can configure like this event here. And all we have to do is configure it. And instead of being local, we can make it run for everybody. And we'll do the same on the other one. So that's running for everybody. So now when I hit this button, like this orange wire, like coming out of pressed and coming out of released, these will only be for me, and because like, or whoever is pressing the button, and then it'll run the event senders, and those are for all. So now, like, it's all the same up to this point, but the part where it changes is when it gets to the event receivers, because it was set for everybody. I configured it and set it to all. So everyone will run these. So everybody will be able to just locally look at these event receivers and turn their lights on or off. So let's try that. Somebody freeze this button. Okay, somebody turn the roll filter on the button. Cool. Yeah, so that looks like it's working good. So if I look at my network heat, it's taking a bit less. Cool. Yeah, the number there is kind of a rolling average, so it isn't completely precise. It's like it takes like the average over a certain amount of time, like a few seconds, I think, and gives you a number there. But it'll be much harder to reach the actual like capacity of network heat doing something like this. Something that's also worth mentioning though is if, for instance, if the lights are all off by default, and I have hit this button, and they all become on, everybody who is currently in the room will have received that event. So like they will be able to turn it on fine. But if somebody joins the room at that point, they won't have known that I pressed that button. So something you can do to fix this is, like, for instance, this is literally just like bound to a toggle button. You could take out another event receiver, and you could configure it to player join. Cool, player join. And we talked a bit about this before, but this event will run for everybody in the room. So this is another place where networking comes into account. So let's take out if player is local. And fortunately, this chip has a little port on it. Like the player join event receiver has a player port to tell you who's actually joining. So we'll hook that up into if player is local. So right here at this wire, this is running for everybody. Once I pass it through this chip, this top exec will only run if you yourself has joined the room. So what you would do if you wanted to build something like this is you take is pressed. We can just do it here, I guess. Take is pressed, run that through an if chip. Actually, we don't even need an if chip. We can just take another one of these event senders. So that should still be local. Wire that up from is local to run the event sender. And then get on here, you can just hook it up to the is pressed port on the button. since this will always be the same. Right now, toggle buttons are always synced, so if I see it pressed, you'll see it pressed, even if you just join the room. So that'll take care of that. When somebody joins the room, they'll see if the button is pressed and then turn the lights on or off. So that'll really help you save a lot of network heat if you were making like a large scale room like that. Cool. Any questions?
All right. Do we have an example for them?
Oh, for them to work on? Did you do anything, Snug?
Yeah. No.
Okay. Here's something I was thinking about would be kind of cool. Do you remember what we did last semester, Snug?
No.
Okay.
Oh,
message.
what?
I think this is pretty similar to what we did. Make a button where when you press it, it will take. Well, first it will prompt you with a prompt local player chip to type in the name of a player, and then when you type that player in, it will convert the name of that player from a string. It will convert them into the actual player using the get player like from account name chip, and then it will show them a subtitle that says hello, their name, and then like from whoever it was that pressed the button. You'll want to use an event sender, like a custom event, and send it. Use like the send to player option. You can configure the event sender and configure it only to go to a specific player. So that will be helpful there. You could even like customize it to like send a specific message that you send with another player prompt message chip. Cool. Does that sound good?
Yep, sounds good. All right. Good luck, everyone.
Yeah, that's what we did last time.
Yeah.
Doug, my laptop was like straight up dying, so it just came on screen. It seems to be okay here.